In part 2 of this unit, we're going to look at what we call quadrant trigonometry. So these are angles that are in the one of the four quadrants. So think of this as quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So for example, we could have a 30-degree triangle in quadrant 1. That will be the same as a 30-degree triangle in quadrant 2. So we talked previously about why the ratios of 30 degrees are going to be the same as the ratios of 150, because basically we've drawn the same triangle, the same measures, but in different quadrants. So we always start at 0 and we measure in the counterclockwise direction. So this would be 30. This would be 150. So 150, the terminal arm, which is the hypotenuse, or where the line ends, or the angle ends, this is called the terminal arm, lands in quadrant 2, and then we connect to the x-axis to create a triangle. So at 150 degrees is creating a triangle in quadrant 2 that has what we call a related angle, or I think in the ministry they call it a reference angle, that is equal to 30 degrees. So it's always connected to the x-axis, never to the y-axis. So this diagram is often called a unit circle because you have all the angles. The radius is 1. A unit circle means the radius is 1. And it's just showing all the different measurements and where they exist in the quadrants. So for example, 45 in quadrant 1 is coterminal, or is the same reference angle or related angle as 45. So 45 in 1 is the same as 135 in quadrant 2. It still creates a 45-degree triangle. So related angle is a concept that you need to understand, and also terminal arm. So it might ask, let's just go on to the next page. Okay, so going back to our unit circle here. So the signs on the unit circle are going to vary. Let's just erase all this, we don't need this. I'll put that in a separate spot. So the signs on the trig ratios are going to vary according to the quadrant. So I'm just going to put reference angle is angle between the terminal arm, or the hypotenuse, and the x-axis. Okay, so the trig ratios will vary according to the quadrants that we're in. So for example, let's look at that 30 again. So let's say we had 30-degree triangle or angle in quadrant 1. So we've got an x, a y, and an r. This is the angle. So in quadrant 1, the sine ratio is opposite, so that's y over the hypotenuse, which is the radius of the line, or the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tan is the opposite over the adjacent. So all three ratios are positive, because in quadrant 1, x and y and r, the hypotenuse, are always positive values. And also remember that the hypotenuse will always be positive because we determine the hypotenuse by Pythagorean theorem, which means we're going to square x and y, so that will always be positive. If I draw the same triangle in quadrant 2, now x is negative because I'm in the negative part of the x-axis, y is still positive, and r is still positive. So if you look at the three trig ratios in this quadrant, sine is y over r, so that's still positive. Cosine is x. Well, x is now negative, so cosine is now negative in quadrant 2. And tan is y over x, and the same thing. Tan is now negative because the y is positive, but the x is negative. So the only ratio that remained positive was sine. If we go to quadrant 3, same triangle. In quadrant 3, both x and y will be negative. The hypotenuse remains positive. So sine is negative because it's negative y over r. Cosine is negative because it's negative x over r. And tan is negative y over negative x, and two negatives make a positive. So in quadrant 3, only tan is positive, both sine and cosine are negative. And if we go into quadrant 4, x is positive, y is negative. It's in the negative part of the x-axis, or the y-axis, and the hypotenuse is positive. So in quadrant 4, sine is negative because it's negative y over r. Cosine is positive because it's x over r. And tan is negative because it's negative y over x. So only cosine was positive in quadrant 4. So this creates what we call the cast rule. The cast rule allows you to determine which ratios are positive in each quadrant. So in quadrant 1, all of them are positive. In quadrant 2, only sine. In quadrant 3, only tan. And in quadrant 4, only cosine. For a minute. So it might ask for a coterminal angle that have the same terminal arm. So it might say find a coterminal angle to 420 degrees. So 420 degrees, we are going clockwise. So all the way around is 360. So one complete circle or one complete cycle is 360. So I would want to know, well, how much is left after that? So 420 minus 360 is 60. So we'd have to go another 60 degrees to land at the same spot. So 420 would be all the way around plus another 60. So 60 degrees is coterminal with 420 because they both have the same terminal arm. They both finish in the same spot. So this is the terminal arm. They both have the same terminal arm. You could also go in the clockwise direction, which is negative. So let's say we had this 60-degree angle. I could also go in the negative direction, which is clockwise, and end up in the same spot, have the same terminal arm. So what would that be? Well, that would be 360 degrees all the way around, not quite there at 60, so 300 degrees in the negative direction. So if I went negative 300, I would land in the same terminal spot as 60, going in the positive direction. And you can think of 360 add up to 360, so we end up in the same spot. So that's what coterminal is. So this is summarized here. The cast rule allows us to determine which ratios are positive in each quadrant. So in quadrant 1, all, quadrant 2, only sine, quadrant 3, only tan, and quadrant 4, only cosine. The other piece of information that we are going to be using are what is called special triangles. And special triangles give us exact values for a 30-degree angle, a 60-degree angle, and a 45-degree angle. These are the most commonly used angles. So we have these ratios of the measurements of the sides. So let's look at a 45-degree angle. If I draw a 45-degree angle, oops, it is actually an isosceles triangle because both angles would be 45. So let's say we have a unit circle where the two sides are 1. If I want to find the hypotenuse, I would say a squared plus b squared equals c squared. So I've got 1 squared plus 1 squared equals c squared. That's 2. 1 plus 1 is 2, and I'd square root. So the hypotenuse would be root 2. So if I have a 45-degree angled triangle, so the two angles are 45, the ratio of the sides is always 1 to 1 to root 2. So for example, if I had a 45-degree angles and the sides were 2 to 2, then this one would be 2 root 2. I'm multiplying each side by 2. So they're always in the same ratio. Right? No matter what, it doesn't matter how big or small the triangle is, if they're a 45-degree angles, they're always in the ratio 1 to 1 to root 2. And we have a similar triangle for 30 degrees and 60. Those sides are always in the ratio 1 next to the 60, root 3 next to the 30, and 2. And again, with Pythagorean theorem, 1 squared plus root 3 squared is 1 plus 3, right? Root 3 squared is 3, which is 4. And so C, the hypotenuse, is 2. So we can use this information. We can use the cast rule. We can use the special triangles to find values or ratios of certain ratios and also the angles. So what do we mean by this? So this says find the exact value of the following. No decimal value. So in this unit, you should not be using decimals at all. So it says find the exact value of sine 30. So I'm just going to draw my triangles here. I've got one that's 45. And I've got one. The 30 and 60 can always go in the same triangle because they add up to 180. So I always have these special triangles handy. So it says what is the exact value of sine 30? So I find 30 degrees right here. Sine is opposite over hypotenuse. So sine of 30 would be 1 over 2. If I want cosine of 30, cosine of 30 is adjacent to the 30 over the hypotenuse. So cosine of 30 would be root 3 over 2. Sine of 45. So here's 45. Sine is opposite over hypotenuse. So that equals 1 over root 2. So all I'm using is my special triangles to find these ratios. Tan of 30. So let's tidy this up a little bit. I'm going to redraw them so I get a clean picture here. So tan of 30, here's the 30, the 60, 1 root 3, 2. Tan of 30 is opposite, which is 1, over adjacent, which is root 3. Now, these last three are called reciprocal ratios. Sometimes they're called secondary ratios. So sine, cosine, and tan, we can find the reciprocal ratio. We can flip these over. So instead of doing opposite side compared to the hypotenuse, I can do hypotenuse compared to the opposite. Instead of doing adjacent over the hypotenuse, I can do hypotenuse over the adjacent. And instead of doing opposite over adjacent, I can use adjacent over opposite. Well, these have to have different names. We can't call them the same name. So the reciprocal of sine is called cosecant. The reciprocal of cosine is called secant. And the reciprocal of tangent is called cotangent. So I'll just write these down here. So it's cosecant, abbreviated to CSC. Secant is abbreviated to SCC, and cotangent is abbreviated to COT. So these are called reciprocal ratios. So it's really the same as the primary, except we're just reversing them inverse sides. So if I want secant of 45, secant is a reciprocal of cosine, so it's going to be a hypotenuse over the adjacent. So I'm going to look at my 45-degree special triangle, and it's 1, 1, root 2. So the reciprocal would be the hypotenuse, which is root 2, over the adjacent side, which is 1, which I could just simplify to root 2. Cosecant is a reciprocal of sine, so it's going to be a hypotenuse over the opposite. So I'm going to look at my 60-degree angle. I want the hypotenuse is 2, and the adjacent side, or the opposite side, is root 3. And then cotangent of 30. Cotangent is the adjacent over the opposite. So I'm looking at cotangent. I'm looking at 30. Adjacent to the 30 is root 3. Opposite the 30 is 1. I could just simplify that to root 3. Now you might get a combination of exact values or ratios, so I can just find them separately. So sine of 45, I'm going to go to my 45-degree triangle. Sine is opposite 1 over hypotenuse root 2. I'm going to go and find cosine of 45. So cosine of 45 is the adjacent, which is 1, over the hypotenuse, which is root 2. And then I'm going to find cosine of 30. Cosine of 30 is the adjacent, root 3, over the hypotenuse 2. And that is squared. So I can see that squared. So now I'm going to simplify. So I'm going to multiply 1 over root 2 times 1 over root 2. So 1 times 1, the numerator is 1. Root 2 times root 2 is just 2, because root 2 times root 2 is root 4, and the square root of 4 is 2. And then I'm going to square root 3. That would just be 3. And then I'll square the 2, which makes 4. Now we need a common denominator. So my common denominator is 4. So I'll multiply this by 2. So it'd be 2 over 4 plus 3 over 4 would equal 5 over 4. So you just find the values separately and then you simplify. In these questions we had the angle. We wanted to find the ratio. In this question we can also work the other way. If we are given the ratio, we can find the angle. So the reverse, we're given the ratio, we want to find the angle. So there's several steps to do this. The first step is to determine the quadrant my answer could be in. You're always going to get two answers. The sine ratio is a positive value. 1 over root 2 is positive. So I'm looking at the cast rule and I'm going to decide which quadrant sine could be positive in. Well, it could be in 1 because all ratios are positive, and it could be in 2 because sine is positive in quadrant 2. So I know my answer is going to be in quadrant 1 or quadrant 2. Then I'm going to label the sides that I were given. I was given the opposite side and the hypotenuse. Opposite, so this is the angle that is connected to the x-axis. So the opposite to that angle is 1, the hypotenuse is 2. Oh, sorry, root 2. And then I want to match it up with the special triangles. Well, I know that that looks like the 45-degree triangle because the hypotenuse of the 45-degree triangle is root 2. So I know that looks like the root 2. So this related angle is 45 degrees. Once I've found that related angle, I can state my answer. So theta is always starting at 0 and going in the counterclockwise direction to the terminal arm. So in quadrant 1, it would just be 45 degrees because that's from 0 to the terminal arm. In quadrant 2, I'm not quite at, so here's the terminal arm. The terminal arm is not quite at 180, so I'm going to do 180 minus the related angle because we're 45 degrees short of 180, so we're going to subtract the difference, and that gives me 135. So that is my second solution. So here's the steps. Cast rule to determine quadrant. That's the first step. What quadrant is it in? Step 2, label the sides. Which two sides have we been given? Number 3, match it to a special triangle. What triangle does it look like? Number 4, find the related angle. Based on that special triangle, what angle is it related to? And then the last, once you know the related angle, then you can determine the solution. So those are the steps you always go through. It looks like a lot, but it's not that many. Okay, so cosine negative root 3 over 2. So I'm going to draw my cast rule, that's the first step, and determine the quadrant that it's in. It is negative cosine. So cosine is negative in quadrant 2 because only sine is positive, and quadrant 3 because only tan is positive, which means that the other ratios are negative. It can't be in quadrant 1 because they're all positive, and it can't be in quadrant 4 because cosine is positive in quadrant 4. So it must be in 2 and 3. So I'm going to draw my triangles, 1 in 2 and 1 in 3. I've been given two sides, so label the sides, adjacent and the hypotenuse. So the adjacent is root 3, hypotenuse is 2. The root 3 is the number that's negative because it's in the negative part of the x-axis, and the hypotenuse is never negative. Okay, so what triangle does it look like? Well, it looks like the 30-60 one, because the 30-60 one has a hypotenuse of 2. And I know there's a root 3 in the 30-60, so the 1's always adjacent to the 60, and the root 3 is always adjacent to the 30. So which angle is adjacent? I'm looking for this angle here. Which angle is adjacent to the root 30 or the root 3? It's 30. So the related angle is 30. So this angle's 30 and this angle's 30. So now I can find my answer. We always start at 0 and we go to the terminal arm. So in quadrant 2, it will always be 180 minus the related angle. So that's 150. In quadrant 3, now you're past 180, so it'll be 180 plus the related angle, so that's 210. And that is my solution. Okay, let's do one more. So tan of positive 1. So tan is positive in quadrants 1 and 3. Now, since I'm drawing a triangle, I have to have two sides. So 1 is 1 over 1, right? Because 1 divided by 1 is 1, and tan is opposite over adjacent. So the opposite is 1, the adjacent is 1. Opposite 1, adjacent 1. In quadrant 3, both the x and y are negative, so that's why it's positive, because I have negative 1 divided by negative 1. Which special triangle does it look like? Well, it looks like the 45, because 45 sides are 1 and 1. So the related angle is going to be 45 degrees. So this angle's 45 and this angle's 45. Once I've determined that, I go from 0 to the terminal arm. So in quadrant 1 it would be 45. And then in quadrant 3, I'm past 180, so 180 plus 45 is 225. Okay, so just follow those steps. Cast rule to determine quadrant, label the sides that you've been given, match it up with a special triangle, find that related angle, and then you can solve the question. You might get reciprocal ones. Same steps apply. Cast rule also applies to reciprocals. So for example, if sine is positive, so is cosecant. If tan is positive, so is cotangent. If cosine is positive, so is secant. So not only the cast rule, but also their reciprocals. So cosecant is a reciprocal of sine. So wherever sine is negative, so is cosecant. So quadrant 3 and 4. Cosecant is the hypotenuse over the opposite, so it would be negative 2 over 1. So the hypotenuse is 2, the opposite is 1. The 1 goes with the negative, just because it looks like it's with the 2, it doesn't have to be. Negative 2 could be negative 2 over 1, or it could be 2 over negative 1. Right? As long as there's a negative in there, it doesn't matter where you put it. So in this triangle, the negative goes with the 1. It doesn't really matter with the solution. I want to look at the related angle. So what triangle does it look like? Well, it looks like the 30-60 because the hypotenuse is 2. So this is 60, this is 30. So if this is 1, this is root 3. So which angle is adjacent to the root 3? The 30. So these related angles are 30. And so my solution is in quadrant 3, I'm past 180, so we're going to add the related angle to 180, so that's 210. And then if I go all the way around to quadrant 4, I'm not quite at 360, so in quadrant 4 you're going to do 360 minus the related angle, which is 330. Okay, in these last two examples on this page, you might have to isolate for sine before you solve. So if I have 2 sine theta plus 1, I need to isolate for sine before I can solve it. So I'm going to move the 1 to the other side and then divide by 2. So sine is negative 1/2. So you might have to rearrange a bit to find that ratio. I'll do my cast rule. Sine is negative, so it would be in quadrant 3 or 4. Sine is opposite over hypotenuse, so opposite, this is my related angle, so opposite is negative 1, hypotenuse is 2. So what triangle does that look like? That looks like the 30-60, makes this root 3. So the related angle is going to be 30 because the 30 is always adjacent to the root 3. So related angle is 30. And so theta in quadrant 3, where 180 past 30, so 210. And then in quadrant 4, where 360, we're not quite at 360, so we'll subtract the related angle, that's 330. And then in this example, again, we have to isolate for cosine, so let's move the negative to the other side, and then we'll divide by 2. So cosine theta equals 1 over root 2, or 1 over 2, I should say. So we'll do the cast rule. Cosine is positive in 1 and 4. Cosine is adjacent over hypotenuse. So what triangle does it look like? It looks like the 30-60. And the related angle is adjacent to the 60 and the 1. So this related angle must be 60 because it's next to the 1 side. So the related angle is 60. So now we can solve. So from 0 to the terminal arm is 60. And then we're all the way around here. We're in quadrant 4, so we're going to be 360 minus that related angle will be 300. Okay, in these last two examples, you might have to factor. If it's a square, you're going to have to factor. So sometimes it's easier to replace the trig ratio with a different letter. So if I say sine x is going to be the letter m, 2 sine squared x would be 2m squared. Sine x would be m. So sometimes that's easier to factor just visually. You don't have to do that. You could just leave it as sine, but some people like to replace it, factor it, and then put it back. So this is a complex trinomial. So I know 2m squared would be 2m times m. I know 1 is going to be 1 times 1. And the middle has to add to negative 1. So it'll be negative, positive. So you're going to factor that whatever method you use to factor. I just did it in my head, but you can certainly use decomposition or whatever method you use to factor complex trinomials. Then I'm going to set each to 0 and solve for m. And then I'm going to put the sign back. Remember to put the sign back or it doesn't make sense. So my two solutions are sine x equals -1/2 or sine x equals 1. So then I'm going to solve just like I did with the other questions. So sine x equals -1/2. So according to the cast rule, that is going to be sine is negative in 3 and 4. We have the opposite 1, the hypotenuse 2, which makes a related angle of 30, because this side would be √3, and the √3 is always next to the 30. So the related angle is going to be 30 degrees. So I can start my solution set here. So when sine x equals -1/2, my solution is 180 plus 30, so 210. And then it's 360 minus 30, so 300. So those are my two solutions for sine x equals -1/2. Sine x equals 1 is a little trickier because whenever it equals 1, -1, or 0, it actually means that you've landed on an axis. So think of a unit circle as a radius of 1. So if I'm on the 90-degree angle, x would be, this point would be 0, 1, which means x is 1, y is 0. And r is 1 because that is the length of the unit circle or the radius. This point here is -1, 0, xy. This point here is 0, -1, xy. And this point here is 0, 0. So if sine x equals 1, sine is opposite over hypotenuse, or opposite is the y, hypotenuse is the r. So think of x, y, r, right? So sine is opposite, which is the y, r is the hypotenuse. So I'm looking for the angle where sine theta is 1 over 1, because that would give me 1. So which point has an y of 1 and an r of 1? Well, looking at the first point, y is 1, r is 1. So that would make sense. That's the 90 degree. At 180, y is 0. So that's not going to work. At 270, y is -1. So that's not going to work. And at 360, y is 0. So sine is 1 at 90 degrees. It'll make more sense when we do graphing, but we haven't done the graphing yet, and that is another way to solve it. But since we haven't done graphing yet, we'll have to do it this way. And you can always check on your calculator. It's pretty easy to check these on your calculator. I could just type in sine of 90, and you will see that it equals 1. Okay, so if it equals 1, -1, or 0, it's going to land on an axis. So it's either going to be 90, 180, 270, or 360. So my solution set is 210, 300 for sine x equals -1/2, and 90 for sine x equals 1. Okay, let's do this question. So I'm going to factor it. So I'm going to let cosine x equal m. So cos squared would be m squared, cosine would be m. I'm going to factor. It's a simple trinomial. Two numbers that multiply to get 2, and then add to get -1 would be -2 plus 1. I'm going to solve the root. So m equals 2, m equals -1, and then I'm going to put the cosine back. So don't forget to put cosine back or the answer does not make sense. Okay, so cosine x equals 2. If you look at your special triangles, so 2 cosine is adjacent over hypotenuse. Well, there is no adjacent side that's 2. In the 45, it's 1 and 1. And then in the 30, 60, there is no side that is 2, except for the hypotenuse, but that doesn't work because cosine is adjacent. So adjacent to 30 is root 3, adjacent to 60 is 1, so it's not there. So if we did cosine on our calculator to find the angle, we could do inverse cosine, and you will see that it comes up error. That's because cosine and sine cannot be greater than 1. The ratio will never be greater than 1. If you get a cosine or sine ratio that's bigger than 1, you will get error. And that's because sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. Both of them are divided by the hypotenuse. What do we know about the hypotenuse? Well, it's always the longest side. And so if we have a fraction here and the number on the bottom is always bigger than the number on the top, you will never get a number greater than 1. So that is why sine and cosine can never be greater than 1. So cosine x is an invalid solution. It just comes up as error. So the only solution we have to deal with is cosine x equals -1. So remember, x is the adjacent side, x over the hypotenuse r. So because we're at -1, we've landed on an axis. So this point here would be 0, 1. This would be -1, 0. This point would be 0, -1, and 0, 0. So where is x -1? Here. X is -1 here. And the radius is always 1. So if I get to 180, at 180, x is -1, the radius is 1, that gives me -1 over 1, which gives me -1. And you can always check, do cosine of 180 on your calculator, and you'll see that it equals -1. So that is my solution.